This is not a film about conspiracies. This is a reverse engineering report. Look at your screen. Do you see these points of light? Each dot represents a reflected laser pulse. Together, they form the exact three-dimensional map of a stone block with a mass of 1,650 tons. Before I tell you what we found in this data, I need to tell you what should not exist there. Baalbek, Lebanon, at 1,170 meters. 3 consecutive sub-millimeter LiDAR scans have mapped every single stone surface with structural precision. And within this data, the anomalies emerged. This three-dimensional architectural mesh provides an absolute structural layout of the Baalbek sanctuary. Every perimeter wall, colossal platform, and foundational layer has been meticulously digitized. This digital reconstruction allows us to analyze the true, unprecedented scale of the complex. Our primary point of analysis begins here. The Temple of Bacchus, often referred to by historians as the Small Temple, it is actually larger than the famous Parthenon in Athens. But while its monumental columns capture historical focus, the true structural paradox lies buried beneath its foundation layers. Moving to our second point of interest, the Temple of Jupiter. Today, only 6 colossal columns remain standing, yet they represent the largest columns ever erected in the Roman world. Towering at over 20 meters high and weighing 150 tons each, they press down upon a foundation that hides an even greater engineering mystery. Next, the data leads us into the Great Courtyard, an immense open-air forum stretching across nearly 50,000 square meters. This vast space was designed to overwhelm the senses, surrounded by hundreds of columns, many of which now lie shattered on the ground, leaving behind a massive field of architectural ruins. Dominating the center of this plaza stand the remains of the Great Altar and the ablution water basin. The altar was originally a monumental, multi-story stone tower designed for massive public rituals. Next to it, the highly detailed basins held thousands of liters of water, engineered with precise drainage channels cut directly into the bedrock. Looking at the overall layout, the system maps the massive perimeter podium wall. This colossal retaining structure was engineered to stabilize the entire artificial plateau, lifting the sanctuaries high above the surrounding landscape and anchoring thousands of tons of stone into the bedrock. According to the core principle of forensic engineering, stone does not lie, unlike historical texts, unlike local legends, and unlike academic interpretations. The geometric data of a stone is objective, quantifiable, and verifiable. And the geometry of Baalbek raises questions, to which we do not yet have an honest answer. First, anomaly. The joining tolerances. The 3 blocks known as the Trilithon, each weighing between 800 and 1,000 tons, are positioned at a height of approximately 7 meters from the ground. The 2019 LiDAR scan measured the joints between these blocks. Result: the average gap between the blocks is 0.3 millimeters. Not 3 millimeters, not 30, 0.3 millimeters. For context, a standard sheet of paper is 0.1 millimeter thick. Thus, the 800-ton blocks are joined to a precision of 3 sheets of paper. To understand this level of precision, we must look at a comparative analysis. A typical Roman stone construction operates within a tolerance of 5 to 15 millimeters. The Great Pyramid of Giza, renowned for its incredible ancient engineering, achieves a staggering 0.5 millimeters. Yet, the Baalbek Trilithon surpasses both, dropping to 0.3 millimeters. This puts a collection of 800-ton ancient blocks closer to modern aerospace engineering, where NASA space components require a tolerance of 0.0 to 5 millimeters. We applied reverse engineering to this tolerance, meaning we started from the final result and calculated backward to find what technical conditions must have existed to produce it. Step 1. Surface contact analysis. The LiDAR scan gives us the exact topography of the contact surfaces. They are not perfectly flat. They have a slight curvature under 0.01 degrees. This means the surfaces were either precision chopped with extreme accuracy or polished. Polishing, the abrasive smoothing of stone, is a process that can produce tolerances below 0.1 millimeters. But polishing an 800-ton block across a surface area of 40 square meters requires, first, a reference platform leveled to a precision of 0.01 degrees. Second, a fine abrasive applied uniformly. And third, a system for continuous flatness verification. Did the Romans possess these tools? We do not know for sure. But the tool marks left on the surfaces of the Trilithon blocks tell us something completely fascinating. The photogrammetric surface scan, with a resolution of 0.5 millimeters per pixel, shows that the tool marks have a strictly unidirectional orientation. Not circular, not chaotic, unidirectional. This suggests a linear tool, not a rotating one. A tool moving continuously in the exact same plane, a sort of fixed guiding system. No documented Roman tool possesses this characteristic. They simply couldn't achieve this level of linear precision on such a massive scale. But the mystery of these megaliths in Lebanon doesn't end here. In the next episode, we will analyze the two inexplicable anomalies discovered in this ancient area. Stay tuned!